Hello, I am Aliye Izzat Kashti. Today's lesson is about getting to know packer mode. Packer mode refers to packaging, which has many applications in industry. It's used in industries such as cement, gypsum, and food products, including packaging sugar, packaging salt, packaging flour, and similar items. In the SEWHA brand, the weighing indicators that have this mode include the SI weight indicator, 400R, the SI indicator, 410, and the SI580E indicator. That means these three models of indicators support the pallet packer mode. So these three models of indicators have the pallet packer mode. For teaching packer mode, we have chosen the SI580E indicator because compared to the other two models, the SI580E weight indicator has more packer modes. In other words, it has three packer modes: packer mode 1, packer mode 2, and packer mode. If we enter function 223, which is also referred to as function number 223, on the SIP580E indicator and set it to number 4, our indicator will enter what is known as packer mode 1. If we set 223 to number 5, the indicator will then operate in packer mode 2. And finally, if we set function 223 to number 6, packer mode 3 will be activated. Now, today we want to get more familiar with these three different modes related to the packer. Alright, the very first mode that I would like to introduce and explain to you in detail is called packer mode 1. As we have already mentioned earlier, if you set function 223, which is a specific configuration parameter, to the number 4, then our indicator device will enter what is known as packer mode 1. How to actually set these functions, including the step-by-step process, will be demonstrated practically and visually later in this tutorial, so you will be able to follow along. This diagram that you see here on the screen is directly related to packer mode 1, meaning that the relays of the SI580E indicator, when they are set to packer mode 1, will switch on and off according to the logic and sequence shown in this diagram. The way this system works is as follows. First, we need to set two set points for our indicator device. We consider the first set point as the main target and the second set point as the dribble, which is a finer adjustment. Of course, it is also possible to set a third set point, which is referred to as free fall or extra drop, and this third set point is optional depending on your application. Free fall or extra drop is used in cases where, for example, we set the indicator to cut off the relay at exactly 5 kilograms. But since this is a mechanical device and there is always some delay, by the time the gate actually closes, a little extra material might be dispensed. So instead of exactly 5 kilos, it might be 5 kilos and 100 grams, or even 5 kilos and 200 grams. That extra amount that might be dispensed unintentionally is called free fall, and we can account for that extra drop here by setting the third set point. As I mentioned before, this is optional, and in cases where free fall occurs, you need to set it to ensure accuracy. Now, regarding the relay operation, to start the process, we must press the start button. We connect this start push button to one of the digital inputs of our indicator, and when we activate that button, our indicator essentially starts or runs the process. When we press start, both output 1 and output 2 are activated simultaneously, meaning they both turn on at the same time. How long do they stay active? Well, that depends on the set points and the logic defined in the diagram, which we will discuss in more detail as we proceed through the tutorial. According to this diagram here, which you can see displayed on the screen, it says that when our current weight, the weight that is being measured at this very moment, becomes greater than or equal to set point 1, which is the first threshold or target value we have set. When this specific condition happens, our first relay, which is an electrical switch used to control the circuit, will actually turn off. The same principle applies to output 2. When our current weight, again the weight being measured, becomes greater than or equal to set point 1 minus set point 2, which is the difference between the first and second set points. Let me explain this better with an example to make it clearer. Suppose we want to package sugar and our target amount, the quantity we want to fill, is 5 kilograms. When we use the SI580E indicator, which is a specific weighing device, for this purpose and set function, D223 to number 4, we enter what is called Packer Mode 1. In Packer Mode 1, we have two-stage control, meaning we can control two gates or valves. For example, to fill 5 kilograms of sugar, imagine we have a fast fill gate, which allows sugar to flow quickly, and a slow fill gate, which allows sugar to flow more slowly for precise filling. We set our target amount, that is the first set point, to 5 kilograms. For the slow fill gate, let's say we want it to close when the weight reaches 3 kilograms, and when the weight reaches 5 kilograms, the fast fill gate also closes. This is usually how it works in filling machines. Both gates open at the same time. When the weight reaches a certain amount, the slow fill gate closes, and when the weight reaches the target amount, the fast fill gate also closes. Well, this is how it works in all packers and in all places where packaging is done. To further clarify, the reason for using two gates is to ensure both speed and accuracy. The fast fill gate allows the majority of the product to be dispensed quickly, while the slow fill gate provides fine control as the target weight is approached, minimizing the risk of overfilling. This method is widely used in the packaging industry, especially for granular or powdered products like sugar, flour, or rice, where precise weight control is important. The use of relays and set points in the control system allows for automated operation, reducing the need for manual intervention and improving efficiency. In summary, the diagram illustrates how the control system manages the filling process by monitoring the current weight and activating or deactivating the relays based on the set points. This ensures that the packaging process is both fast and accurate, meeting the desired target weight every time. So in the example I gave you, when our measured weight reaches a total of 5 kilograms, that means my first output is deactivated. And when our weight reaches the value of the target minus the dribble, meaning we've set our target weight and are now accounting for the dribble, that is when the next step or process is triggered. We've set the target at 5 kilograms and the dribble at 2 kilograms, meaning when our current weight reaches 3 kilograms, our second gate closes. Now, I've demonstrated this practically, and you can see it at the end of this tutorial. This mode also has a third output, which is an additional feature provided in this configuration. The third output operates based on time, specifically when our first and second outputs are deactivated after a period of T1 seconds. Output 3 is activated for a duration of T2 seconds, and then it deactivates after T2 seconds have elapsed. So this third relay in this mode works based on time, meaning that after T1 seconds have passed, output 3 is activated for T2 seconds and then it turns off. T1 and T2 are adjustable parameters, and they can be set using function 239 and function 240 respectively. Also, as you can see in this diagram, there is a fourth output, which is actually referred to as the empty range value. As you can see here, using function 201, we can assign a value to it. When our weight is less than that value, output 4 is active, but when our weight reaches that value, output 4 deactivates. Usually in industry, this fourth output is used as a case detector, which is a common application. For example, in industries like cement packaging, they use a bag in which the cement is placed. The empty weight of the bag, for instance, is 200 grams. This output 4, which is function 202, is set to 200 grams. As long as the weight is less than 200 grams, output 4 is active. As soon as it detects the case weight, what happens to output 4? Let's consider this in more detail. When the system senses that the weight has reached the set value, output 4 will deactivate, indicating that the bag is no longer empty and is now filled to the required threshold. This process ensures accurate detection and control in automated packaging systems, providing reliability and efficiency in industrial operation. It deactivates, and we can use this for starting the operation. Now, the next mode is Packer Mode 2. As mentioned earlier, if we set function 223 to the Packer value, our display enters Packer Mode 2. In this mode, we use 3 set points, meaning we have a 3-stage control here, or in other words, we can command 3 valves. The relays operate according to this diagram. The way it works is that we assign the target value to our first set point, the second set point is called dribble, and the third set point is called bulk. The fourth set point can also be considered as free fall or additional drop. When we press start, output 1, output 2, and output 3 are activated simultaneously, meaning all 3 valves are activated at the same time. Now, when our weight reaches the difference between SP1 and SP2, the second valve, or output 2, closes, meaning it deactivates. To elaborate, the process begins with all 3 outputs engaged, which allows for a rapid initial flow. As the weight increases and approaches the first threshold, the system detects when the difference between the first set point and the second set point is reached. At this moment, output 2, which controls the second valve, is deactivated, reducing the flow rate. This stepwise reduction in flow ensures greater accuracy and control during the packing process. The use of multiple set points allows for a more refined and controlled operation, minimizing overshoot and improving the overall efficiency of the system. Each set point serves a specific purpose. The first for the main target, the second for dribble or fine adjustment, the third for bulk addition, and the optional fourth for free fall or any additional drop that may be required. This multi-stage approach is particularly useful in applications where precise control over the filling or packing process is essential. By carefully managing the activation and deactivation of each output, the system can achieve a high degree of accuracy and repeatability. This method is widely used in industrial automation to optimize performance and ensure consistent results. And when our current weight reaches the difference between the first set point and the third set point, that is, when it reaches SP1 minus SP3, our third output deactivates, or that valve closes at this point. In this mode, we also have a fourth output which operates based on time. After all our valves, or more precisely all our outputs, are deactivated, the fourth relay activates after a delay of T1 seconds and stays active for a duration of T2 seconds. You can set T1 and T2 using functions 239 and 240. The next mode is when we set function 223 to the value 6, which is Packer mode 3. Packer mode 3 is similar to Packer mode 2, meaning its operation is the same as Packer mode 2, with the difference that the fourth relay is no longer time-based. The fourth relay now operates in the empty range mode, and you can set its value in function 201. That means whatever value you assign to function 201, whenever the weight is less than that value, this relay will be active. As soon as the weight reaches that value, the fourth relay deactivates. Well, the next thing we need to do is to learn exactly how to set the set points on the SIP182E display unit. To do this, simply press the F button, which you will find on the front panel 4 times in a row. After pressing the F button 4 times, the word Setup will appear on the display screen. If you then press the F button 1 more time, Set P will appear on the display. Now, once Set P appears on the display, if you press the tail button, you can adjust the target values as needed. But if you press the Hold button instead, you can set the values related to free fall right here in this menu. So if after the message or indication labeled as Set P appears on the display screen, we proceed to press the button marked with the letter T, then the display will change and Set T will show up. This Set T is specifically for entering or adjusting the target values that we want to set. So if our intention is to set the set points, we need to use this particular mode, which means we should utilize the target setting function. Now, after Set T appears on the display, if we again press the T button, the display will change once more and set point 1 will appear. At this stage, we are required to enter the desired value for the first set point. After entering the value, we press the F button, which serves the purpose of saving the value that we have just entered. Then, if we press the Hold button, the display will show SP2, which stands for set point 2. We then enter the value for the second set point, and once again, we press the F button to save this value as well. If we then proceed to press the print button, the display will show SP3, which refers to set point 3. At this point, we enter the value 3.3, and after entering this value, we press the F button to save it. The value will be stored in the system. I have performed all of these steps in the following demonstration, and you can watch them being carried out in detail at the end of this video. Each step is shown clearly so you can follow along and understand the process thoroughly. Alright, the next thing we want to do is the wiring method in Packer mode. Here, the back of the SEWHA display is shown. We need two push buttons. One will be used as the start button and the other as the stop button. We also use a switch as the power supply. Additionally, we need a 24-volt DC switching power supply, and here we are also using load select switches. First, we connect a wire from the positive 24 volts to our switch and then connect it to the positive terminal of the SI580E display. We also take another wire from the negative terminal of our power supply and connect it to the negative terminal of our display. In this way, when we turn on the switch, the display will power on for us. The wiring method for the load cell is as follows. Our load cell actually has a total of 4 wires. The first one is red, which serves as the positive excitation. The second is white, which acts as the negative excitation. The third is green, which is our positive signal wire. The fourth is blue, which is our negative signal wire. For the start button, we connect one side of it to the COM terminal. We connect one of our inputs to it, and we also connect the COM, which stands for common terminal, of our inputs to the stop button. Here, in this particular setup, we have used input 1 and input 2 for demonstration purposes. Let me explain in more detail that this SIQ88E weight indicator, which is a specialized device used for measuring and displaying weight, has a total of 4 digital inputs. 2 of these digital input terminals are located at the bottom of the indicator, and the other 2 are situated on the upper board of the indicator. For the Packer remote control system, we only need to utilize these 2 specific inputs, which means we only require one push button for starting the process and another push button for stopping it. A very important point to keep in mind, and one that should not be overlooked, is that for both the start and stop functions, you must use normally open push buttons, which are switches that remain open until pressed. As I mentioned earlier, this is crucial for the correct operation of the system. The section related to the digital inputs has one COM. From that COM, we take one wire and connect it to one of the push buttons for start, and we also connect another wire to our second push button, which is for stop. We connect input 1 directly to the start button, and we connect input 2 directly to the stop button. For our output devices, we can use an electrical contactor. For example, if we want to control a solenoid valve, we can use a contactor. I carefully took a wire from the positive terminal of the power supply and connected it to the common terminal of the relays. As we know, this display has 4 relays, and one of these terminals is related to. The common terminal among these relays is connected directly to the positive terminal of the power supply, ensuring that all relays receive the necessary voltage to operate correctly. Then you connect the first output to the first contactor, which is responsible for controlling the first part of the circuit, and similarly you connect the second output to the second contactor, which manages the second part of the circuit. Also, we take a wire from the negative terminal of our power supply and connect it to both of our contactors, thereby completing the electrical circuit and allowing current to flow properly. The wiring I just explained is specifically related to the Packer Mode 1 configuration, which is a particular operational mode for this system. For the start and stop push buttons, we also need to make some adjustments to ensure they function as intended, which we will do together shortly in the next steps. If we enter function 233, which is related to our first digital input, as we said earlier, we assign the first digital input to the start button, so we need to set function 233 to the value 8, which corresponds to the start function in this configuration. We assigned the second digital input to the stop button, so we need to set function 234 to the value 9, which is the appropriate setting for the stop function. Next, we'll get familiar with how this display works in practice so you can see the real-world application of the setup. We connected the SI580E weighing indicator to a SEWHA load cell, model AB120, with a capacity of 25 kilograms, and first calibrated the display to ensure accurate readings. I'm placing a 2 kilogram weight on the load cell, and as you can see, the display is now fully calibrated and shows exactly 2 kilograms, confirming the accuracy of our setup. We did the wiring as I just explained, following each step carefully to avoid mistakes. Here we used two 24-volt signal lamps instead of relay outputs, which serve as visual indicators for the outputs. I connected the first output to this red signal lamp, which lights up when the first output is active, and the second output to this other signal lamp, which illuminates when the second output is triggered. We also used a start push button to begin operation, making it easy to initiate the process. As I explained earlier, we need to make some initial settings before the system can operate correctly. First, we enter function 223 and set it to the value 4, which means we're setting the display to Packer Mode 1, enabling the specific features required for this mode. To enter the functions, you need to press the F button 4 times in a row, which brings up the function menu on the display. The word Setup will appear on the display, indicating that you are now in the configuration mode. Then, press the Tear button, and using these directional keys you see here, you can change the function values to match the required settings. Our first function, as mentioned, is 223, which is crucial for the correct operation of the system. By following these steps carefully, you ensure that the system is configured properly and will function as intended. Each connection and setting plays an important role in the overall operation, so it's important to double-check your work at each stage. If you encounter any issues, reviewing the wiring and settings can help identify and resolve problems quickly. This thorough approach helps maintain the reliability and accuracy of the system, ensuring consistent performance over time.
So to begin with, I set this to function 223, which is the first step in the process. After that, I press the F button, which is located on the control panel, to enter function 223. As we discussed earlier, we need to set its value to 4, so that means we enter 22304. Once I have entered that value, I press the F button again, which saves the setting into the system's memory. This completes the configuration of the first function that we needed to set up. Now moving on to the second function, which is function 233. This particular function is directly related to our digital input, specifically the start push button that we previously connected to digital input 1. The relevant function for this input is 233, and as I explained earlier, we need to set the value of 233 to 8. By doing this, when we press the push button, our display will automatically enter Packer Mode Start, which is the desired operation. So that covers function 233. I press the F button once more and set its value to 8, ensuring that the configuration is properly saved. This completes the setup for both functions, ensuring the system operates as intended. We set it to 233.08, making sure to carefully enter each digit and then press the F button to save it, confirming that the value has been stored correctly. Now the next thing we need to do is enter the set points, which are crucial for the operation of the device. I press the 0 button to exit the current menu, ensuring that we are back at the main screen. To set the set points, as I explained earlier in detail, first press the F button 4 times in a row, one after another, so that the word Setup appears clearly on the display. Press the F button once more, and then to set the target mode, press the T button, which brings up the message Set T for setting our target values. As I explained, if I press the T button now, it will be for our first set point, which I set to 5 kilograms, making sure to enter the value precisely. So I set the target value to 5 kilograms, double checking the input for accuracy. If I press the hold button, we move to the second set point, which I set to 2 kilograms, and then I press the F button to save it, ensuring that both set points are stored. We don't need to do anything with the other set points, so I press the 0 button to exit, returning to the main menu. Now, as I explained earlier, if we press the start button, both out 1 and out 2 should turn on at the same time. That is, both of our signal lights should turn on simultaneously, indicating that the outputs are active. I press it, and we see that both our first and second outputs are activated at the same time, just as expected. Here, we've set the target value to 5 kilograms and the dribble value to 2 kilograms, which are important parameters for the process. As I explained, when the weight reaches 3 kilograms, that is the difference between the target and dribble, which is 3 kilograms, when the weight reaches 3 kilograms, our second output should deactivate, and when the weight reaches 5 kilograms, our first output should also deactivate, completing the process. So, I place a 3 kilogram weight on the load cell, our second output should deactivate, and as we see, when the weight reaches 3 kilograms, our second output turns off, and when the weight reaches the defined target value, that is 5 kilograms, our first output should also turn off, indicating that the process has finished as intended. This sequence ensures that the device operates according to the set parameters, providing accurate and reliable results every time the procedure is followed carefully. So I place the 2 kilogram weight on the load cell, and when our weight reaches 5 kilograms, our first output also turns off.